Okay, so, oh, there we go. Nice. Yeah, so in today's talk, we're going to go through a little bit of what is Edge. Edge is this term that everybody uses for different things. So we kind of need to define it on every time we give a talk. We're going to talk through some of the challenges in edge computing and then a little bit about how SUSE Edge addresses those challenges.
So I'll first start with Edge. So we have a very broad definition of Edge. So anything that is not centralized data center or public cloud, we actually treat it as Edge. So as an example, it can be your home or retail store or like car manufacturing, manufacturing factory or moving train, vessel, or even a satellite that can be considered as Edge. So we have very different kinds of Edge. And we actually classify like 3 different kinds. So first one is near Edge. So here you see more like standard form factor servers going like serving 4G, 5G radio applications. So it can be like one server or a half rack or like one full rack, depending on how telecommunication providers configure. So in terms of form factor, it's kind of like more bigger than far edge. So what we see near edge like mostly applies on telecom. And from our product perspective, we have 2 products. One is SUSE Edge for telco, another is SUSE Edge. And the telco product is positioned here. So the characteristic of near edge is this is where we get the toughest requirement in terms of like, okay, I want you to tune your Linux this way. I want you to tune your kubelet this way so that my 5G applications can perform better. So we actually learn a lot of like techniques and the lessons learned from these tough requirements from telecommunication, application providers such as like Ericsson, Nokia, Huawei, or also telco providers like, I guess in America, T-Mobile kind of providers. And we tune the telco cloud like based on their requirements. Next one is far edge, and this is where we the rest of the verticals such as retail, manufacturing, healthcare, and etc. So the form factor can vary a lot. It can be a small like Raspberry Pi, but it can also be a like pizza box server or like even a proper server like that, depending on your requirement. So this far edge is where SUSE Edge stack is positioned for like rest of the vertical. And in terms of the number of devices, what we see in near edge is like from 100 to 1,000. In far edge is actually a lot, like a little bit more, like from thousands to like 10K. And the third one, tiny edge, is like with industrial IoT like devices, or sensors. So the difference between far edge and the tiny edge is in the far edge, you use the devices where you can actually install the Linux. But the tiny edge is so small and we cannot really install the Linux. But we still have to consider how we register them, how we manage them, and how we operate them. So those come into consideration. So from SUSE perspective, we don't really, we're not really directly playing in this area, but we partner with companies like Genesis and other companies to basically better manage the IoT devices for this. So that's the basic definition of edge. So it's actually more than what you can imagine. So anything that's not like public cloud or data center can be considered as edge, and we want to treat it in a uniform way. Next, I want to touch on the common challenges in the edge computing. So first one is like whether it's a telco edge or general edge or your home or like retail store, there's always not enough resources. That's what everyone tells us. So even if I have like half rack of servers, in the end, I end up seeing that, okay, I want to run more applications or not enough resources. That's what we hear. So, and the requirement from application people are simple. With this limited resource, I want you, Linux provider or Kubernetes, to use as little as possible. But at the same time, you need to support me that my application can run at the best performance. So that's usually the requirement, both in telco edge and the general edge. Second one is complexity in deployment and management. So what we often see is a very small team, like 3 people, 5 people, or less than 10 people have to manage hundreds or thousands of sites together. So provisioning has to happen like zero touch, otherwise your team is going to end up spending a lot of time like in provisioning. And what can be a bigger problem is the operation. Like, so if it becomes like manual, then your team ends up spending a lot of time fixing things here and there. And another problem is you have to do it remotely because you cannot send all these technical people to on-site. And some of these may not be even reachable. For example, an extreme case is a satellite. Once you send it to the space, it cannot come back. So we have to do it remotely. Third one is connectivity and the reliability. Because edge are remote, the network conditions are tough. The network bandwidth can be really low. Some people say, yeah, I have to deal with this really low bandwidth, but that's actually kind of common in edge. So, and we also have to deal with air gap requirement. So for example, I always use this example. So there is a vessel. When it comes to the port, it's connected to the network. But when it starts shipping, then it basically becomes like disconnected, which is air gap network. So this is one good example that we, for the edge computing, we have to consider both online connectivity, but also air gap connectivity. And in this ship case, it's intermittent like connectivity. So that's another consideration we have to make. Fourth one is definitely security. So I think I'll go back to the ship example. So one customer we had actually mentioned that we want to have a stack we can just plug in. And once it goes to the ship, all kinds of tampering happens, like physical tampering, software tampering, and we don't want to, we want to avoid that. So that was basically a requirement. So we want to have that kind of, physical security, like a stack that is physically secured, but also in terms of software and supply chain, those are, because edge are very much distributed and the attack surface is quite big, so that should be definitely considered. And the last but not least is the customers we meet, they all have different requirements. So although we try our best, there's no one-size-fits-all solution. So that's one like big requirement, which is actually hard to tackle, but we're trying our ways to, fulfill that requirement. We'll talk about it later. So I'll quickly go over the simplified version of solution architecture. So throughout this week, actually, a number of our guys went through, gave edge related talk, and I'm sure you've seen like different version of this. So basically, we have edge clusters running in edge sites, like hundreds of them, thousands of them, or even more. And left is the management cluster, which is managing these edge clusters. So our foundation is OS called SUSE Linux Micro, or it used to be called SLE Micro. So that's an immutable and like operating system, like which is lightweight and with a minimal attack surface. We'll talk about more later. And on top of that, we provide Kubernetes, which is K3s or RK2, depending on your requirement. So these two are the core of our edge stack. So it's not SLES. And on top of that, if you have like security requirements or if you want to have block storage, we can add the security or SUSE storage on top. But these are completely optional. And we often see the deployments without them. And so here you can run basically containers because it's Kubernetes. And we often see customers saying, OK, not all of my applications are containerized, which is like very common. Then we leverage KubeVirt, vanilla KubeVirt, to run the virtual machines on top of it. So on the management cluster, our management suite is basically based on SUSE Rancher Prime. And first of all, to make sure all these edge clusters get the applications like all together, we use our GitOps tool called Fleet. And what you see as onboarding and the cluster API and Metal 3, those are I'll say in a simplified way, those are the tools we use to make sure automated provisioning and the operation of bare metal operating system and Kubernetes all together. We'll go more into that later. So this is what we offer as an edge. And actually, other products such as SUSE Multi-Linux Manager, or many people will know as SUMA, we also offer it as well if you want operating system level management. So yeah, that's what it is. So we'll touch on the first challenge we often phase in Edge, which is tight resource constraints, and I'll let Andrew talk.
So when we're talking about tight resource constraints, we're talking about a couple different sets of resources. It's both the compute resource and the size on disk and the amount of memory, but it's also the amount of bandwidth that it takes to like pull down updates, right? Because especially when we're talking about Edge, like several of the customers that I've worked with, they have, especially for retail, they might have locations that are on the other side of, say, like a DSL line, or maybe 4G, or potentially even earlier. So with that, there's a lot of places where it really matters, like how much data we're going to be transferring for kind of all the update and initial setup updates, applications, all of that. So one of the first pieces of technology that helps us minimize our footprint is SUSE Linux Micro, and I will probably call it Sleep Micro at some point, just out of habit. And this is really our lightweight optimized operating system. So traditionally with Linux, you would have all of your packages, they're all installed on the host, everything's kind of running all together, and then you likely have dependencies that are shared between those different applications. With Sleep Micro, or with SUSE Linux Micro, we really are forcing a hard partition between the host and your workload on top. And that workload is either containers or virtual machines. And the intention is that you don't install anything onto the host itself. Sometimes that isn't quite doable, especially if we need like kernel modules or other hardware needs there. And then that also means that you can lifecycle all of your applications and your host separate from each other. So that's useful for a variety of reasons. Like I was talking about, like network usage. Being able to lifecycle independently means that you're able to spread across all of the data transfer for updates over time, so you can not saturate your uplink. And then similarly with the immutable operating system and the small footprint of it, it means that there's less packages that you have to pull down, right? So you don't have as much data just to start with. The other thing that is really nice about this operating system is that it is immutable. And so with that, it means that you wouldn't like log into something, make a change, and then have to, if you make that change, sorry, played a concert last night, a little bit tired. So with the immutable piece, the idea is that you wouldn't be going and making changes to each of your systems individually. You would actually make that change upstream, have it deployed across everything. Everything becomes automated. And so you really don't ever treat anything like pets, right? And then because everything is immutable and all of your updates are being managed through snapshots, if you update a package or you update some configuration and you don't like the result, you can just roll back. Or if, say, the system doesn't boot, it'll just roll back automatically. And it'll just go to the last snapshot by default, or you can pull it back to a previous time. And because that's using copy and write, you're not wasting a ton of storage with all those all the different snapshots. This is available for x86 and ARM. The x86 also has the real-time kernel with the real-time scheduler patch in there. I know the slide says IBM Z. I don't know anybody who's using a mainframe on the edge, but yeah. I mean, you could. And honestly,
I think it's more realistic if you're going to do edge things with PowerPC than you are going to do mainframe.
probably, although I haven't run into that yet.
Network here using PowerPC.
Oh, good. Cool. Although I used to do some work with IBM Z, and there's a lot of shared constraints between Edge and Z, turns out. So the next part up in the stack is K3 or is the Kubernetes. We have two options for Kubernetes. We have K3s and RK2. I bet everybody's heard of K3s. Has anybody not heard of K3s in here?
I could be
do it. Yeah, so K3s is a very lightweight and very simple Kubernetes distribution. It is conformant with upstream Kubernetes. But what makes it really interesting is that it's just a single binary that you pull down, and then it pulls down the containers that it needs. Yeah, it's lightweight, runs, I think Kubernetes, or K3s and SL Micro, on my systems we're taking up like 1.5 gigs of RAM, so you can get pretty tight resource constraints there, or resourcing there. But then on the other side, we've got RKE2. This is it was originally created for DoD use cases. So it started off being hardened and certified against DoD standards. But we found a lot of use for telco and also industrial. The big thing, like really the deciding factor in my mind between do you want to go with K3s or RKE2 is if you have either really low footprint or small footprint piece of hardware, K3s is probably going to be your choice. If you need more configurability or optimization options, RKE2 gives you a lot more touch points to change configuration and to tune the system itself. Yeah, so the next challenge is less about the technology and more about the people process, right? Who's actually doing a deployment. Yeah, especially for like retail, you're probably shipping out boxes, and the person who's actually installing them might be like the store manager who doesn't know anything about what's actually running other than how to use it. Yeah, so the questions that we tend to have are like, how do you automate the entire full stack deployment, right? All the way from you plug in a piece of hardware to your entire application is running. And that should be as low touch as possible, and also as as low risk and as low chance for error as possible, right? So the less human intervention you can have, the better you're going to be. Yeah, so how do you simplify the operation and do remote management of these pieces of hardware and the applications on top? Is it possible to manage your operating system and the hardware declaratively? And so one of the things that we've been talking about is kind of like the idea of how do you treat like Kubernetes and everything under as if it was firmware, right? Because your application developer should not care anything below the here's my pod, here's the other pods, or here's my container, and here's what else is in my pod. Yeah, so with that, how do we pull everything all together? How do we manage it through GitOps so everything's nice and declarative? Yeah, how do you get predictable builds? All these fun things. So the first way that we're going to talk about is using Edge Image Builder. There we go. The person who built it, part of it, some of it. Yeah, so the idea with Edge Image Builder, hopefully you like how I say this, but is really we're defining all of as you can see on the left part of the graphics, we are providing a definition of what what should be in the image. We're providing a set of configuration files, and then we're providing a base image for the Linux. We run Edge Image Builder, takes all of those inputs and outputs a what we call a customized ready to boot image. Is that what we're still calling it? Sweet. Yeah, and so that image is what you will take and use to either lay onto your system or use as installation media for all of your systems. Yeah, so that includes everything all the way from like how should network be set up, what user should you have, what packages should be installed, like kernel modules, at the very base case to like should you install Kubernetes, what host should be in that cluster, what applications should be running on that, and it'll actually go and pull all of the container images and pull everything all into one image so that it is you stick in the USB stick and you boot it, it installs, it's completely air gapped, and it just comes up and runs. It's pretty amazing. So currently in Edge Image Builder 1.1, we support ARM images we support x86 images to start with, and then we have ARM64 images in Tech Preview. Yeah, we have enhanced the security by enabling FIPS, and we've improved the build times by caching. Caching the container specifically. This is what a config file would look like. Can y'all read that in the back? We're good? Cool. Yeah, I'm not going to talk through all of this, but you can kind of see how the structure is, and you can see that like for Kubernetes, we're saying, yeah, install 1.30.3, install these different Helm charts when it comes up. Yeah, it's really cool. And here's a quick demo of it. Just a couple minutes, might skip through a little bit of what it looks like booting. A little bit of a technical tangent. The way it works is that it will pull all of the packages onto the image, and then it uses combustion to do all of the installation. So when you boot the machine, it'll do the normal, just install to disk like the self-installer, just the standard self-installer would. And then on that first boot, or first reboot, it will run through combustion and set everything up. Let's kind of maybe that restarted. That's good to know. There's some errors that are always there, even though they aren't errors. There we go. And you can see that, yeah, we're installing the package. We're installing the packages that were requested, and this, yeah, now it's installing the embedded registry. We're using a component called Holler that is also built for the by our government team for DoD use cases. That allows you to kind of move all of your container images and sideload them in a really, really nice way. Installs K3S. Installs K3S, sets everything up there. Yeah. And it should be rebooting fairly soon. You see, yeah, it reboots. You can see that Kubernetes comes up as you expect. So so as far as so we just talked about the image-based provisioning. So there are within zero-touch provisioning. We broke apart the requirements and grouped them into basically 3 different sets of underlying constraints. So the image-based provisioning is kind of what everything is based on, and it's really focused on air-gapped as the base assumption there. The next one is the phone home network provisioning. This is when we're using, this is useful when you are sending devices that are going to be booted on the other side of a NAT gateway, or where you want to be able to do the remote management, but you're not able to actually like manage the device directly, right? It doesn't have a baseboard compute or any way to, to manage like state of the machine. So the way that works is if phone's home, then you tell it what to install, how to install, all of the configuration. And then the third one on the left is what we call directed network provisioning. This is, we've seen primarily used in the telco use case, but also a bit in the manufacturing use case. This is using a component called Metal Cubed in Cluster API. And that actually will reach out to the BMC that are on your servers and tell it to load the IPA image. It gets a bunch of information about the hardware, and then can turn around and provision the operating system and all the Kubernetes pieces on top of it. One of the goals here, the goal here is basically to be able to have Git as your single source of truth for everything on your infrastructure, all the way from the hardware configuration to the applications. Yeah. And with that, we also, and that needs to be the infrastructure and the applications, right? And trying to get all of those kind of merged together. Yeah, if anybody, has everybody done GitOps here? Does anybody not know what GitOps is? Yeah. Yeah, so I guess for the recording, GitOps is basically saying all of your, basically the definition of your declared state should be stored in a single place, specifically Git, and then all of your tooling should just be reconciling back to that state.
Or the way I put it is like, I mean, we all know that all the application codes go into Git. And with the public cloud emerged, actually infra started becoming a code or API call. So even for Edge, which is basically bare metal, we started thinking, oh, why can't we manage Kubernetes or operating system or bare metal, like how we manage the application? We can actually define this infra as code, put it into Git, and that way we can see, for example, what kind of Kubernetes version it is running for, like 10th of cluster or like hardware specs or the OS version. We can put all this information into the Git and we can actually manage how we manage, just like how we manage the application. So that's that's the way I put it in a simplified way. So it's like putting that Git like philosophy lower to bring it down to Kubernetes and operating system and even to the bare metal level. So we can put all this information, because at the end of the day, what you have to manage is not only the application, you have to manage the entire stack. So let's put all this infra, let's define all this infra as a code, let's put it into Git, and let's manage it more efficient way. So that's my way of putting the GitOps into the, yeah.
Cool. Thank you.
Yeah.
Thank you. Yeah, and then last is going to be talking about the no one-size-fits-all.
Okay. So in the previous session, previous chapter, we kind of went through the zero-touch provisioning. I just want to mention a little bit because looks like, I have used this slides for so many times, but it looks like it's not really getting through to some people. So with the Edge image builder, what we basically do is we package everything into one image. So whether you have like 100 sites or 1,000 sites, you can just drop this image and it will like self-boot up. That's how simple that is. So you don't have to do anything. So what we have shown with the EIB, that's based on this. So, and the difference between this and other provisioning methodology is that this one, like we don't really give a linked. So that Edge cluster can kind of communicate back to the rancher. So that's the difference. And so I would say this is the simplest form of zero-touch provisioning, because we still drop ship everything. Like if you have your own application, we can deploy as a Helm chart. If you have your own configuration for the operating system scripts, we can also package that into a single image. So that's still possible. And then I often get a question like, okay, like for blue box and the orange box, like which one should I go for? And the simple answer, the simple answer I tend to give is if your box is a proper server and has an out-of-band management like BMC, then blue box is the way to go. And if not, which happens in most of the verticals outside telco, like retail, manufacturing, whatever, then we actually go with the orange box, which doesn't require the OOB interface on the server. But still, both kind of work like GitOps way, and it kind of goes back to the rancher, so you can manage all these clusters from the rancher. So to the question that, okay, so that was the how we answer to the second challenge that, okay, with a limited number of people, how do I manage hundreds of clusters remotely in an automated way? So that was our answer to that. The third one is there's no one-size-fits-all solution for edge computing. So the first thing we do is we actually do a lot of testing for various configuration. We call it, you might have heard validated design or stack validation. So first of all, we get a lot of questions. Okay, your edge stack, which hardware is it tested against? So our team tests for HP or Dell or Supermicro or even more, and both on x86 and ARM architecture, because in Edge, ARM architecture are sometimes common. And we test against like Intel, AMD, Ampere CPUs. And if your edge has like single server, you may form a single node cluster. We test for that. And if you have like, for example, 3 servers in one retail site, then you may configure multi-node Kubernetes cluster. We test for that too. And the ship case I mentioned in the beginning, the air-gapped network and the online, we test for both network. And we test not only the day one, which is provisioning, I mean the zero-touch provisioning I mentioned earlier for those 3 provisioning cases. Not only that, we also test the upgrade use case. So actually it happened yesterday, but I think also happening like later today or tomorrow. So one thing our engineering team invented recently was something called upgrade controller. It's upgrading your full stack in a GitOps way. So one demo that our guy is showing in the booth area is like they put it like zero-touch provisioning for telco, but essentially, and they'll show you a lot of like YAMLs going through and a lot of amazing things. But what's happening underneath is like, if I put it simply, you have this infra definition in Git, and let's say I have been running 1.29 like Kubernetes version, and I want to upgrade to 1.30. And what I'll do is I'll simply just update that piece of code and and push it, and that will actually trigger the upgrade of Kubernetes cluster on, I don't know, 100 different clusters. So it sounds like a magic, but that's what our engineers have built. So we test those kind of day 2 scenarios as well. And for networking part, we test various CNIs, and this matters more for the telco because one use case they have is they actually expose a pod to have multiple interfaces because that's what telcos do. So we test that with like Maltese combination, but we also test with other kind of CNI such as Kernel and Calico. So SUSE being like an advocate for open source, and our team decided to even publish this QA result as open source as well. And we run this test like daily and also weekly, so you can actually access this site and see like what we have succeeded and what tests have failed. So yeah, that's what we do by validating like various configurations against like different hardware to make sure that like customers' requirements are met, and and so what we observe is every customer has different requirement and different deployment. So the simplest form we see is on the left side, the first step. So going with the operating system and the Kubernetes and dropping some applications, containerized applications on top of it. So without the rancher. So it might be useful with building up the image, spinning them up on clusters. And on the second one, once your edge clusters like numbers grow, you definitely need to consider management. And our answer to that is rancher. And another interesting part from the second one is the customer actually decide to go with their own operating system. So as SUSE, we give you choices. We don't stop you from doing that. But if that's your preferred OS. But the downside is for Edge, we actually provide the full stack. And we provide the automation based on this stack. So, and that stack's core element is our operating system and the Kubernetes. So if you kind of deviate from that configuration and the zero-touch provisioning or the day 2 operations that we have mentioned will not apply. So that is the kind of a big downside, but customers can have their own choices, and yeah, that's like what I'm saying is it's possible, yeah. And the third one is like managing the stack with a rancher. So when your number of sites grow, this is the key. And you can choose to, simplest form is you can choose to manage the application and only the Kubernetes from rancher, or you can leverage the GitOps to actually push all the application to the different clusters and leveraging the cluster API to actually manage the Kubernetes operating system and all bare metal to get all the full stack. The last one is if you, we have a product called SUSE Multi-Linux Manager, or called SUMA, which is a strong product for OS management. So some customers decide to go with going both like Rancher and Suma. So one for more cloud native management and another for operating system management. So this is another possible option.
And using that option, some of the customers that we've seen have gone with this option partly because it gives you more granular control when you use the multi-Linux manager, but it also gives you a bit of a belts and suspenders approach to your management. So, because especially when we're talking about hundreds of thousands or millions of devices, things break. That's just the reality. So if something breaks and you have another connection in, then you have a higher chance of being able to fix something in place. Is rolling a truck to an edge location is just way too expensive.
Yeah, thank you. So yeah, this is actually the ship use case I have mentioned. So they provide I'll say like selling kind of software to the ship, and they decide to create their own like edge stack, and we have been like offering our SUSE Edge stack to them so that they can actually create an edge like cluster and bring it to each ship, and they could like reduce 75% of like time and effort to establish that. So that kind of reaches the end of our presentation. So we have mentioned like 3 big challenges in Edge. First is like tight resource constraints. So to respond as our response, we provide lightweight operating system and the Kubernetes. And the second one is like difficult to manage and the provision. So we provide zero-touch provisioning and also GitOps way to manage the entire stack from bottom to the application. And the third one is to meet the various requirements or like different configurations. We test so many different configurations as part of stack validation, and we give you choices with, depending on your requirement. So those are the 3 things I mentioned. We talked, and so I recently wrote a blog or demo that if you want to try SUSE Edge yourself, and the challenge I often had was I didn't have a additional server, and so what we have come up is thanks to EIB supporting ARM architecture. If you have Apple Silicon Mac, you can try it yourself. You don't need a SUSE subscription to do that. Everything is open source. So we design in a way that it doesn't require SUSE subscription. So you can actually deploy SUSE Edge stack, including the OS, Kubernetes, and even Rancher. And you can play with by yourself. And it all happens by creating an image. So you can just spin up the image. It's going to self-install by itself. So you don't have to configure all this. So yeah, so if you want to try it, you can scan the QR code and try it. And if you want to learn more about Edge, unfortunately, many of Edge presentations happen already, but we still have one coming up later today and another one tomorrow. And you can also drop by the booth to see the demo of EIB or zero-touch provisioning at our booth. Yeah. So I think that's it.
Any questions?
So going back when you were talking about the SUSE Linux micro features, and you mentioned image-based and transactional update, one of the things that I was interested in seeing is differential image updates. So since you use Butterfest underneath for all this stuff, do you guys have a mode in which you can do something like produce one environment where you do the transactions, create the thing, and then have the snapshot, and then be able to send the snapshot out, fanning out to all the nodes?
That is something we have been discussing. There isn't any tooling built for it yet, but there's nothing stopping us. So if that's a requirement, let's do it.
Yeah, the reason I was thinking of this is because a couple jobs ago, I built something similar using this, and the reason we went with having the Butterfest snapshots and transmitting them was because that way we could, this demo here where you're testing this on one machine, you get to set up the workload and validate it, and you can qualify it with something like OpenQA or whatever. And then when you're all good to go and you've checked the box, you can send it indefinitely across all the machines and have a reliable outcome. So that's with conserving on bandwidth when you're sending things to like on satellite networks and stuff.
Yeah, wholly agreed. And
Yeah.
for the recording, the question was about, I guess, delta-based
updates.
yeah, delta updates for the RPMs, or I guess for the
No,
whole
for the
image,
image-based
for the
delta.
Btrfs snapshot, yeah. And yeah, so that is something that's been discussed. And I'm going to look at Joe. Yeah. I keep asking this every year.
Yeah. So I think the Unified Core initiative was only briefly mentioned by Bassett, but as part of that design, there are prototypes for exactly that. And the idea would be to combine this with OCI. So we would then basically package up the update into an OCI wrapper so it can be distributed through the registry. So you don't even have to have like another protocol or use things like Btrfs send receiver. So yeah, definitely we're working on that use case. Still a few options to choose from, but I guess we will most likely end up having an approach where you install a base image and then there are overlay images distributed as OCI artifacts that can be applied, be it in Btrfs, most likely as a Btrfs snapshot, yeah.
Yeah, and I guess along with that, we do already have, obviously, the RPM transactional update-based approach, and I believe the TUKit we've merged the change that allows for the OCI, like, effectively.
Yeah, experimental in 5.0, but it's not actually released to any open SUSE
Right.
distribution yet.
Yeah. So that work's ongoing as well. So soon we'll have those two options, and hopefully a third being the send receive.
Cool.
Yeah.
The send receive one is the one I'm most interested in because basically I would have essentially a lead node that I qualified with a sample of workloads. And then when it passes, then I just immediately start pushing it out in waves.
Yeah, wholly agreed. Yeah, so you get you get the additional predictability, and you also get the smaller update size, right? Yeah.
There was a slide talking about the cloud native journey, where one of these, that one, where one of the second scenario is using a third-party Linux OS. Do you have any additional information about the scenario, like any additional prerequisites or?
It is not a preferred choice, obviously. And that's for, yeah, I mean, Linux is awesome because like everybody has different flavors, and they typically are all really good. The reason that we prefer our own is because when something breaks, we can fix it, and actually we don't have to go upstream and like force changes through somebody else's product, right? We can actually just like go, here's a patch, apply it, we're good, right? And while we work on getting it upstream. Yeah, and then obviously we also build all of our tooling, kind of assuming a SL Micro or eventually Unified Core based approach. So yeah, you'll lose some of the testing and the validation that we do. You'll lose some of the tooling. The main reason that you would go with that way is either you already have hardware with an operating system in place and it just doesn't make sense. A lot of times, I mean, there are other constraints than technology, right? So if those constraints kind of push the conversation towards, yeah, let's just go ahead and get something up and running and get you working on somebody else's operating system, sure, let's do that, right? No real issue. But we can give a significantly better value if we have the whole stack being green. Sorry, and again, for the recording, the question was about the second slide and when we might be using a customer's preferred operating system.
I imagine the case is when you're dealing with hardware that's got only drivers for a particular platform and you're just kind of stuck until it gets replaced.
Yeah, that's another, hopefully for cases like that, we would be able to work with a hardware vendor and get those modules, but
Ideally.
yeah.
We're working on it.
Ideally.
Yeah.
Yeah.
We're working on it. Long way to go.
Zero set done. Seeing none. Cool, thank you.
Thank you.
Yeah, have a good day.